Okay. So on page 168, 8B. And we're supposed to be volume. Okay, and this is 6, 5 here, and 7 there. Okay. They want the volume. So the volume is the formula of the volume is the area of the base times 1/3 times the height. And the height is 6. And the area of the base is length times width, right? So our volume is going to be 1/3 length times width times h, which is 1/3, and it's going to be 7 times 5 times 6. So that's 70 meters squared. Meters cubed. That should be it, right? Ten. This is 35. Might do, no, let's see, no, that's for the problem 14. It says find the volume of the right pyramid. Okay, I'm drawing the wrong thing. I was looking at crossed. Okay, try it again. It says a right pyramid if the base is a regular pentagon. Okay, pentagon is 5 sides. So, it's a regular pentagon. Pentagons. It's a right pyramid base is a regular pentagon. I don't know why I put them solid lines in there. Okay. Those back lines are not supposed to be solid. That's too hard to undo it. And it's a right pyramid, so there's this line that comes down from the top, and that's in the center of that pyramid, and that's a right angle with the base. And each side of that pentagon is 16. The perpendicular distance from the center to one of the sides is 11. So if you go this perpendicular distance from here out, and that distance right there would be 11. And that height is 19 point. This right here is 19.2. So the formula for the volume is 1/3 of the area of the base times that height. And that area of the base, it's going to be each one of those triangles is 1/2 of 11 times 16. But what you can do is you can do the perimeter. You can do 1/2 of the perimeter. And the perimeter is going to be 5 times 16, because there's 5 of those triangles that are 11 high. And then times the 19.2. So the reason they do you understand why the perimeter, I mean, each triangle is actually 1/2 of 16 by 11, and then it's 5 of them. So it turns out to be the perimeter, which is 5 times 16. So now then, we can just do some canceling. This is 8. And the 3 will actually reduce this. 6.4, right? So then we have 5 times 8 times 11 times 6.4. Probably still, to be safe, we should use a calculator. A bit too much for me to do in my head. That was 6.4. That was so. 6. I think I got all the numbers right. 2816. So I did 1/3. That was 2816, wasn't it? And that is 8 cubed. volume of each of the following cans round to the nearest whole number. The juice can. So it's R equals 5.3, and the height is 17.7. Well, that's the volume is the area of the base times the height, and the area of the base is pi r squared, right? Times height, pi, and then it's 5.3 squared, 17.7. Put that in the calculator. Times 17.7. Maybe 1562 if you round to that off. That's approximate. And that's centimeters cubed. And the B, this was A. And the B, they got the diameter. It's 13 centimeters. So we're going to have to get the radius. So that's going to be 13 over 2, 6.5 centimeters. And so the volume is pi 6.5 squared times, and then height is 14 centimeters. So approximate to 1951. And that is what centimeters cubed. Okay, here's the one I was trying to draw. That 14. Maybe go back to that. I'm going to have to redraw it. And it says find the volume of each right circular cone round to the nearest whole number. So the volume is 1/3 of the area of the base times that height. And I didn't draw one thing in there. That distance across there is 15 inches. That's 35 inches high. So this is going to be 1/3. Area of the base is 1/2 of pi r squared, and then times that height. Well, r is equal to the diameter of 2, so r is going to equal 15 over 2. We can put in with accuracy 7.5. So 1/3 times 1/2, and drop the brackets, times pi times 7.5 squared times 35. Don't look like anything is going to really drop out. So I'm just going to put pi 7.5 squared times 35 and then divided by 3 and divided by 2. So pi second pi times, that was 7.5 squared, right? Times, what did I have? What was the other thing? Times 35. Then I can just divide it by 3, and I don't have to worry about bracketing it. And then just do this divided by 2, and it'll just 1031. And those are all the same units, so it's inches cubed. This was the A part. B part. And it says these are right regular cones. And what we need to do for volume, we need to know this perpendicular distance. And it's a right regular cone, so this is a 90 degrees to that. What we're given is this distance is 48, and then we're given this side is 40. So what we have to do is we're going to have to look at this right triangle that's over here, where it's this thing over here, that right triangle right there, and we're going to have to calculate this distance right here. So we're going to have to calculate this. I'm just going to call it A. This distance here, B, is going to be half of that 48, which is 24. So we need to know A for height, because this then, that A is going to equal the height of our triangle. To put into the formula, volume equals area of the base, 1/3, area of the base times height. For that height, we're going to have to calculate A. So A is going to equal the square root of 40 squared minus 24 squared. And that's going to be H. And then the radius is actually the 24, which is the B. Formula is 1/3 pi r squared times H. So I'll just put all this in at once. So 1/3 pi times 24 squared times the square root of 40 squared minus 24 squared. I could get rid of that 3 in the denominator by factoring out that 24, but it does not make it less of a calculator problem, so I just put it in there. So it's pi times 24 squared times square root of 40 minus 40 squared minus 24 squared divided by 3. So it's pi times 24 squared times square root 40 squared minus 24 squared. Get out from underneath there. And then divided by. And because that's all times, we don't have to worry about bracketing or anything. Because it's all just multiplying and dividing. Should be it. 19,302. Just take a look, make sure we did it right. It's 1/3 the area of the base. The base is pi times 24, half of that diameter, which is 48, 24 squared. And then the height, it's got to be square root of 40 squared minus 24 squared. Show the height. And we had 19,302 approximately. And it is feet cubed. Feet cubed. Says find the volume of the following spheres round to the nearest whole number. So what's the volume of the sphere? 16. Formula there. 4/3, isn't it? Pi r cubed. A by r cubed, right? 4/3 pi r is 2.3 cubed. This is inches. So I can remember. Well, there's nothing that will reduce with it. It's a calculator problem. Now just go 4 times pi times 2.3 cubed divided by 3. So just go 4 times pi 2.3 raised to the 3rd. Get out from under there. On top of there. Divided by 3. 51. Okay. 51, and that was inches cubed. B, they're giving you diameter, and the diameter is equal to 2 times the radius, so the radius is what we need to have. 22, which is 24 over 2, which is 12. and then it's just volume equals 4/3 pi, and then R is 12 cubed, and it's inches or meters.
Professor, where'd you come by the 24?
Does it say 24 meters? Oh, I'm on 15. That's where I was looking at 15. Thank you.
Yeah.
6.7. I'll just leave it that way. Cube. Okay. Gotta put a bracket. 6.7 divided by 2 raised to the third power, and then I can just divide that by 3. 157. Approximately equal to, and that's kilometers cubed. C. And it says the circumference equals 108 pi meters. So volume is 4/3 pi r cubed. So what are we going to have to do?
Refresh me on the circumference formula. What's
Pi
pi
times
squared?
pi times the diameter.
Pi.
Circumference is equal to pi times the diameter. The radius equals the diameter over 2. So we could take this, solve it for diameter, right? Diameter equals circumference over pi, and the radius is going to equal, it's 1/2 of circumference over pi, 2 pi. But the circumference is what? 108 pi? 108 pi over 2 pi. So that's 54. So in the volume is 4/3 pi, and then it's going to be 54 cubed. So it's going to be important that you remember all those formulas, I guess. It's 4 pi 54 cubed divided by 3. 4 cubed divided by 3. Wow. That's big. So big, did I do it right?
You have to divide it by 3, I think.
I did, didn't I?
I'm not sure.
Yeah, it's right. It's right there. The radius is 54, right? Four-thirds pi 50, so 4/3 pi 54 cubed.
That's what I got as
Six,
well.
huh?
That's what I got as well.
659, 584. Right?
Unless we're both wrong.
Yeah. 659. What was it? 584.
Mm-hmm.
And what was that? Meters cubed.
Just meters, now it's meters cubed.
Yeah. Okay. 18. Says use dimensional analysis to perform each of the following conversions for approximate answers round to the nearest hundredth. So A, 15 to 115 yards cubed, and then they want this in feet cubed. So what are we? How are we going to do it? What is the relationship?
Well, there's
1
feet
yard
per
is what? 3 feet. So if you go 1 cubed y cubed, you got 27 feet cubed, right? 3 cubed.
Square or cube?
Cubed, because it's
Resulting
115.
in the cube, right?
Yeah. So now if you want to have feet cubed, so what do you have to do? 115 yard cubed times 27. This is supposed to be cubed over 1 yard cubed. So it's your yard cubes go out and you're going to get feet. So it's 115 times 27, and then you'll have feet cubed. I don't want to do it in my head. Times 27. $31.05. Cubic feet, right?
Just say it for 1 second, please.
I'll just write underneath it 42 millimeters cubed, and you want it in centimeters cubed. So what's the conversion have to be? How many millimeters in a centimeter?
10 millimeters per centimeter.
Okay, 10 millimeters per centimeter. So then what do you have to do? Cubic, you're going to have 3 zeros, aren't you? Millimeters cubed is 1 centimeter cubed. So now what are you going to do with that? So you do 1 centimeter cubed, right? Over 1,000 millimeters cubed. This 0.042 centimeters cubed. Correct? Okay. So they got 2.3 meters cubed, and they want it to yards cubed. you're gonna have to do. What are your common relationships? You know, the one, if you look in the book, like you, in the back of the book, it has the relationships. If you're gonna use those, they have 1 inch is 2.54 centimeters, exactly. Centimeters. So what are you gonna have to do?
Convert it back to meters.
Meters to centimeters, centimeters to inches, inches to yards, right? So you'll have to know the conversion from meters to centimeters. So what do we say that was? 10, I'll write this horizontally across. It's 10 millimeters. No, I want to go centimeters to meters.
1 centimeter to meter, right?
Isn't it 100 centimeters in a meter?
Huh?
Is that right? Is it 100 centimeters in a meter?
Mm-hmm.
So you're going to have to cube these things, right? So this is going to have to be cubed to get a cube. You're going to have to cube this, and cube this. And then you're going to have to do what's the relation? You're going to have it in inches, right? Cubic inches. What's the relationship between inches and yards? 36 inches in 1 yard. So then you're going to have to cube this and cube that, right? So you want to convert it to centimeters, so you're going to have 100 cubed centimeters cubed over meters cubed. That's 1 meter cubed. Then you want to convert it to inches, so then you have inches cubed over 2.53 cubed centimeters cubed.
254.
54. And then you're going to have to go to yards, right? So then you're going to have 1 yard cubed over 36 cubed inches cubed. Your inches cubed cancel there, your centimeters cancel, the meters cancel. So we've done it, right? And it's going to be 2.3 times 100 cubed over 2.54 cubed times 36 cubed, and we'll have yards cubed, right? .3. It's the only thing that isn't cubed. Times 100, right? Cubed. We don't have to worry about dividing. We can just divide this thing item by item. Well, one of them was 36 cubed. Remember that. Cube, get out. And I got to divide again. What was the other? 2.54, wasn't it?
Mm-hmm.
And then we have to cube it. 3 point, do they want to know rounding off or approximately? Round to the nearest 100. Tens, 100. So that'd be 3.01, right? Equals 3.01 yards cubed. I think on that sheet that I gave you, those unit conversions are in there, aren't they? Okay, 20. Following sketch is a pattern or net for a three-dimensional figure. Use the dimensions given to calculate the volume total surface area of the three-dimensional figure formed by the pattern. Round to the nearest whole number. So for the volume is, that's going to be a hexagon base, right? And it looks like a regular hexagon. And then it's going to be the area of the base times the height. And so how do you figure the area of that hexagon? If it's figured logically, it's a triangle, and then it's six-sided, so it's going to be 6 times the one side, so it's a perimeter is going to be 6 times 12. It's 1/2 the perimeter times that base, and then you're going to have to multiply it times the height. I don't know why I put cap.
So I got a very different answer on the last one. It's probably my arithmetic.
3.01.
Yeah, I didn't get anything.
Oh, 3.01 is right, I'm sure. But just a second, let's finish this.
Okay.
The perimeter is going to be 6 times 2, right? And then the height of that hexagon is going to be the square root of 3. This is that area of the base, and then that overall height is going to be 12, right? So I can do a 3. So I'm going to actually do 6 square root of 3 times 12. I guess to have exact number, you'd have 72 times the square root of 3. And I would take, this would be centimeters what? Cubed. Because it's volume. Otherwise, it's going to be an approximate number. That would be exact. Now, the area is going to be what? It's 2 times the area of the base, isn't it? Plus, and then it's going to have to be each one of those rectangles, and or triangle rectangles, and you got 6 of them. You actually get the perimeter, right? It's the perimeter times the height. And the area of the base is once again just like the area we had there. It's 1/2 of 6 times 2 times the square root of 3. Oh, yeah, that's the area of the base. Then plus the perimeter is 6 times 2 times that height is 12. there's actually 112. 112 comes out of there. Plus 12. So it's 12. Square root of 3 plus 12, right? It's 165. Ah. What's that? Approximately. And that's centimeters squared area. Did you figure yours out, Vince?
I left out the cubes.
Okay. Okay, we'll do one more and then we'll quit. 22. It says, how does the volume of a sphere change if its radius is doubled? So the volume is 4/3 pi r cubed. So this is the volume. Now if you double the radius, so volume 2 is going to be 4/3 pi and then 2r cubed. So this is going to be 4/3 pi and it's going to be 2 cubed r cubed. So if you go take the 2 cubed out in front and you do 4/3 pi r cubed, then this is 2 cubed and this is the old volume. So volume 2 is going to be 8 times volume 1. That's 8. All right. Okay. So you guys got to track me. You got a rodeo. We'll finish this chapter up Wednesday. We won't have a test on Friday, but we'll have a test Monday.
Okay. Do we have a quiz Monday? I mean, this Wednesday also?
I don't know. Do you want to have a quiz?
It doesn't matter.
I mean, a quiz means that no one's hurting for grades.
We have a test Mondays though.
Test on Monday. That's what I'm thinking. I mean, I could make a quiz up.
That's okay. They can do all of that one.
Don't be cute.
Okay. We might have to start into chapter 4. We'll have to. On Friday, we'll have to do chapter 4.
Professor, just leave that up for 1 second.
Yeah.